It just someone let me know if it does not look bad as it was last time. Is it good? Can you see the CAD?
Yep.
Excellent. Okay. So I just wanted to give a quick update and concept overview of the intake. Sorry, I wasn't able to come on Saturday this time, but the general idea, as Andy noted, was that we would have this intake over the bumper. This is the bumper. It would be over the bumper and it would come down like a 4-bar linkage, as many of the rapid React robots did last year. So currently my plan is that if you look on the CAD channel, you'll have to like scroll up 1 or 2 pages. But if you look in the CAD channel, I did have some preliminary testing done just with my own hands and a drill and some flex wheels for the cone stuff. And so I think I'm very confident that I could get both cubes and cones in any orientation up this bumper and into our robot, into some kind of indexer where the arm can take it. So the main update I wanted to give is like I have the dimensions if anyone wants them. I also posted a sketch of it. And you might notice like I have some holes that might be empty and I have a lot of empty space so that we can just drill more places if we ever need to prototype more. But these are some current designs. I also saw another team online with some similar dimensions that I was able to copy. I don't know how to pronounce their name, and I also forgot it. But if you have any questions, let me know. I know like a lot of people from, especially Lamar, was asking if they can do some jobs, and we had some fun with that on especially Thursday, I believe, yeah, Thursday, when a lot of people were doing the FRC things instead of Vex. So yeah, if you would be interested in working on this, let me know. And if you have questions or suggestions about this, please do tell me, because I think it's going to be the most important subsystem at the beginning, because this is what we get our pieces from. And that's all.
Yeah, this is a good update. And for people that don't know, the laser cutter, we started using it on Saturday to cut some stuff for the Swerve dummy modules. And so you probably smelled it if you were in the room, because it does kind of leave a burning smell too. But hopefully when this design is somewhat finalized, they'll throw those wooden plates on and they'll cut 2 of them that have the geometry that Samuel just showed, and we will be able to do a prototype. And I think that's a great way to quickly prototype something, and if it works out well, then we can make it more solid out of metal or out of plastic that will hold up in a real competition environment, because the wood will get shattered, but it's a good starting point to see how it all works. So that's how we'll do some of our first iterations. Gregory, you want to go next?
Sure. Let me share it. Okay. We were talking about our arm on Saturday, and although we looked at the elevators right near the end, we were saying, okay, elevators seem to be either a fixed arm, a single joint fixed arm, or some kind of elevator would be the current like designs that we have. And after we looked at the elevator stuff, we found that the only elevator that was really available was the 50-watt elevator, and that was really expensive. So we were trying to find out how to do the fixed arm, the single joint fixed arm. And yesterday we were doing some talking in the CAD channel, and I kind of had an epiphany. Sid had the idea of the double jointed arm, but we kind of figured out this is just a normal double jointed arm is way too hard it's way too complex, and we don't have any experience in doing it. However, I think I found like a good medium between a single joint fixed arm and a double joint arm. So this arm that I have here has a restricted, doesn't have a full 360-degree motion on this joint. So it's restricted by these 2 pieces here. So the idea is that we can, well, the main problem with the single joint fixed arm was that we couldn't physically reach far enough, or we couldn't fit it inside the starting perimeter. So the idea with this arm is that we first start like in this configuration, and we're able to deploy it once we're trying to score, right? So I think this has a solid. It's not too complex because we can use either pneumatics here or just we can. This makes it into a two-state type of arm instead of a full joint. So I think this is a good medium between the single joint and the double joint. Yeah.
I do have a question about that. Can it reach inside the robot, like enough to grab it from the ground intake?
Let's see. I know on Friday. Oh no, not Friday. On Saturday, we were saying that we were gonna have two fully separate systems. So theoretically, yes, but I don't think we're gonna super worry about that.
So my main concern about having an arm like this that's so long touching the ground is once you start doing that, there's a good chance that this arm is going to take a pretty heavy side impact.
Mm-hmm.
And once that happens, the arm might not work so well anymore. So I think we really should try to segment between doing ground stuff with maybe a separate mechanism, and then if they somehow like work together where it gets stuff from the ground and then hands it off to another arm, okay, that's fine. But I think we probably should keep them separate from a standpoint of just two separate mechanisms that will one does the ground and one gets off the shelf.
Sorry, Andy. Are you talking about the whole idea of the arm itself, or just the reaching from the bottom part, reaching to the ground intake part?
I would imagine this arm has the geometry to pull things off the shelf and
Mhm.
also score all the way to the high zone, right? That's kind of what you're.
Yeah, that's the point of
And
it.
that's all I expect from it. If it
Okay.
can do fancier things like somehow exchange between a ground pickup, if we have a separate ground mechanism that brings it into the robot and then it can pick it up from the robot, okay, that would be cool too. But I don't think that's necessary at this point. So.
Also, one of the benefits of this is it's like you could have theoretical like 180-degree motion from the front of the robot to behind the robot without having to turn the robot. Like the arm could face behind the robot depending on how we structure our like piece manipulator on the arm. So that you could drive over to the shelf, pick something up, and just swing it around the robot, if that makes sense.
Yeah, the other idea I like is, let's say we're really struggling to get the bottom joint to work. We still could have a way to just fix this thing, and it might not be able to score the high, but it could still score the mid, right? If we just
Let me see.
fixed it.
Probably we just pass in something like that. Yeah. Definitely.
Why does it need the bottom joint?
Because it can't reach otherwise. Like I said
Can you
before,
not make an arc with just the high and the medium posts?
what do you mean by that?
Like the only points you have to reach, or the only minimum requirements are just getting the high node and the medium node, right? Can you not make an arm that can, or a linkage that can just complete that arc?
No, we can't. From our testing, from our other concepts, not a single fixed arm, like something that fits within the frame printer like this, is just physically unable to reach the high without interfering with the base of the robot itself.
Yeah, I think we have more work to do here. I don't think any of this is going to be absolutely the direction we're going to go without any changes. We still have a lot of stuff to think about, and it might be a complete, redesign if we've come up with something different. So the arm is going to be, I think, the most complicated mechanism of the season. We're just going to have to keep thinking about it. To save time, I know Anthony wanted to talk I think we're going to switch over to him. Are you ready, Anthony?
Yeah, I'm ready. Okay, can you see the thing? The arm?
Yes, it's seen.
Okay. So this arm is based off of the DiscoBot elevator. No, it isn't exactly one-to-one, but it's kind of how it would look like. So how it is this base thing is at a 30-degree angle with the actual base and has a length of 30 centimeters. And the first stage of the elevator is 31 centimeters. And like this little gap, stopping point between them is 3 inches. What this block also moves, which will hold the arm, which can also move. And if I position it like this and take the measurements, you can see that it just barely reaches enough distance to be able to get to the high node on it. If it's also grabbing the cone 8 inches above the tip of the high node, it has just enough clearance for it. And it can also just be really compact. So it has a decent starting position. But this arm is kind of finicky. I'd probably mess with that later.
Yeah, Anthony, I encourage you to look at 2582, from Lufkin. They have an open alliance thread on Cheap Delphi, and their design is very similar to this, and it's pretty well refined and thought out. But it is something we should look at carefully because they've tried to eliminate a lot of the complexity of the elevator and keep kind of the same profile of what you're doing here. Might be worth checking out and understanding how their design works because I think there's a lot of similarities and it is worth considering.
Okay. Oh yeah, also something that I realized that this is the cab model for like the DiscoBot elevator. What I realized that this thing is massive from the base to the very top of this thing. It's 91 inches, which is way bigger than we need it to be. So if we do get the DiscoBot elevator, we have to like make it shorter somehow, or we just like never extend it past a certain limit.
Yeah, with elevators, complexity goes up with stages. So this, I believe, is a 3-stage, is what they call it. I mean, maybe there's some semantics on whether it's 2 or 3, but there's multiple stages involved here. So the inner square is going to be 1, and you have a middle square, and then you have the outer square, or outer rectangle, I guess is a better geometry term. But yeah, once you add this many stages, it gives you a lot of height, but it also adds the complexity. So keeping it to like a simpler stage elevator, like 2 stages or 2 rectangles, makes it a lot easier.
Okay.
But that's great. Thank you for sharing that. Sid, I'm going to ask you to share the version of the robot so far so everybody can kind of see what's going on.
Okay, so hang on, let me pull it up real quick. I have the dummy modules if you want me to talk about those really quick.
Yeah, whichever is fastest. You can
All right.
pull it over.
So basically, the dummy modules have been designed to be cut out of 3/16 wood on a laser cutter, and then they can be fitted together using Vex V5 screws and Keps nuts. So they shouldn't be very hard to assemble. It's 4 parts, and then you just stick a 4-inch Vex Omni wheel in there. This current Omni wheel is actually an AndyMark Omni wheel, so it's not exactly the right dimension, but I couldn't find the Vex Omni wheel in MKCAD for some reason. But as you can see, it's really close to the profile. I think it's like 0.07 inches difference in height. So theoretically with these, you could have 2 swerve modules and have a fully functional swerve drive robot, which is nice for our case because there's multiple schools, and it's also just useful for testing purposes because then you can kind of get a feel for the height of the robot without having the actual chassis right in front of you.
Yeah, one of the main reasons we like this style is we want to keep our mini swerve robot together as long as possible and get as many, programming runs as we can on that before we're ready to convert. But we also don't want to slow down the building of the robot. So this could help us kind of still test out all the robot mechanisms, but it won't actually be very functional yet. But as soon as we're ready, we can swap out swerve modules and get the robot, fully drivable with all 4 swerve modules. So
Also, a note on the mini swerve. At the meeting on Saturday, we got all of the wheels to align. The encoder issue is fixed. And when we were driving it, all of the wheels were facing the right direction. And when we went into the turn function, it was also facing the right direction. So we're really close to getting that to work if it's not already functional. Also, here's just the drivetrain with the bumpers. So we were thinking about having one-piece bumpers with a pin and slot, like a pin and latch mechanism on aluminum angle, but we might revise that to be 2-piece bumpers just for ease of switching stuff out at competition. Right now we just have a basic belly pan, some gussets that we lightened a little too much, and then over here we have a mock-up of the charge station ramp just to kind of see how different heights of bumpers change the impact that the swerve modules would take when driving up the ramp. Because the last thing we want to do is damage a swerve module rushing up the charge station. So
yeah,
I think
this is a great angle that everyone should think a lot about. If we go very slowly, the robot will not go up the ramp. So it's an important problem. We need to make sure the bumpers are as high as possible. Otherwise, if they're too low, or if we mount them a little lower than what the rules or than the maximum height that we can get, we're probably going to have more issues getting up the ramp. So we need to always think about this because we don't want to ruin our chances getting up the ramp because we just, missed it by half an inch. So important graphic.
Mm-hmm. But in addition to this, we've just been working on more of those block arm concept diagrams. I feel like the arm, I think we need to do some prototyping on that for just like not a full scale design yet, but just kind of with aluminum extrusion or pipes or some PVC tubing or something, just to get an idea of complexity and that kind of thing.
Yeah, and I think it's also important to start providing like Sawmill with intake dimensions, like a volume of here's what you have for your intake, and that way he knows exactly how wide he can get it and maybe how much space he can fit it into the robot. And then same goes for the arm system. We might want to just throw like the Everybot arm on here and just use it as our block of like here's how much space we're allotting, and then here's how much space we're allotting to the intake, and then they can work with those volume boundaries to try to make sure they fit.
Okay. Speaking of the intake, there's one more thing to share. We also came up with like another intake design. So it's a 4-bar style intake, kind of based on what Spectrum was talking about on their build blog. And it just flops out vectored intake wheels. I saw that some teams are using those for cones as well as cubes to center the cubes. And then there's actually a way to center the cones, which was pretty interesting. But it's just pneumatically actuated, or it could be motor actuated. But the distances haven't been finalized or anything, and it's just kind of a rough sketch as well. That's all for me.
That looks good. Does anybody have any other things to add? Okay. Well, I'm gonna just close off the